Hi everyone, welcome. This is the Oracle Autonomous Database Learning Lounge. I am Marcos and I see be a part of the product management team for Autonomous Database. And today we're going to have a very amazing session. We're going to actually be talking about all the different developer tools that you can use with Autonomous Database as your data platform. So on the day today, we have Paul Parkinson and Germán Viscuso, and they're going to be sharing with you guys all these different topics and different capabilities that you already use on your day-to-day in developing different languages, different Kubernetes clusters, Grafana, right? You're going to be using OpenAPIs for REST, different polyglots or different languages, right, that you program with. You're going to see transactional features. You're going to see globally distributed database with spatial graph machine learning. You're going to see Kafka and TxEventQ. So, and also the vector search and AI capabilities. But all of these used in conjunction with the Autonomous Database, okay? So you're going to see all the different frameworks and stacks and these capabilities. And throughout the day, we're going to have basically access to your questions. So we're going to be answering your questions, anything that you want to ask. Please make sure that you put it in a Q&A, okay? We're going to have product managers monitoring the different questions, and we're going to be able to answer you there. When you come back, if you're watching this on YouTube, for example, you can look at the links below. And one of the links is there. That one takes you back to the previous recordings of all the different sessions we've had, and then links as well from those sessions and slides, okay? All right, so speaking of links, I'm sharing with you some links right now. If you take a look at chat, you're going to see some links there. And basically, that's where you get to the more information about Autonomous Database. You get information about samples and things like that. But also, if you want to ask your question, right, one good option is to put it in our Oracle Slack webs. We have an Oracle Developers Slack workspace where you can actually go in, you register yourself, and you can search for Oracle Autonomous Database, right? Just like it's on the screen, and you can ask your question there, okay? And again, thank you very much, Paul. Thank you, Germán, for joining today. I'm going to let you guys start sharing, and again, welcome.
Wonderful. Thank you so much. Yeah, I've been looking forward to this. Let me share my screen. Okay, can see the screen?
Yep.
Excellent. Yeah, so I'm Paul Parkinson. I've been I started developing when I was 10. So I've been developing for 42 years. So you can figure out how old I am. And so I went from core development into a developer advocate role in the Oracle database. My focus was always transaction processing. So Oracle database, the king or queen of that. And so the last 4 or 5 years, I've been a developer advocate. And Herman is similar. I won't date, but he's been at it for a while.
Yeah,
And so
absolutely.
yeah. So he's been a PM in the database for a while, and he has a strong background in observability. So that's kind of where we became buddies in the observability space. So getting into it, because we're covering a lot here. What we're doing is kind of the opposite of maybe the usual. We're walking through an application and demo, and in the application is the PowerPoint or the description of what's going on. So very quickly, this is everything we're going to show here is in GitHub. This is the QR code. We'll bring this up again. This is a live lab workshop that'll be published, and you can get all of the source code and all of this in this repo. And the nature of this application is that each of these on the left here is a different page. And they are all, if I hide kind of the details, there is a financial vertical theme. So that you don't need to be in financials to have a takeaway from this. But these are kind of the basic, financial tasks. You're looking at financial APIs, you're viewing accounts, making deposits, making stock purchases, getting financial insights and things like that. And then the other kind of information on here is what tech we're showing to achieve this financial task. So for publishing financial APIs, we're using ORDS that a lot of people were interested in, et cetera, et cetera. And then the third line on here is actually an external customer reference that is using this technology for exactly this use case. Obviously, it's simplified, but for example, for globally distributed database, Amex is indeed using that for their credit card purchases and things like that. So it's to make it relevant. Like I say, I don't have the Amex implementation in this app, but that's kind of the way it's structured. And then for each page, you can pick your favorite technology or whatever it is and just run that page. So it's extremely modular in that sense. You know, you don't have to build everything here. You can pick what you want, but at the same time, it is sharing a schema. So we try to work the best of both worlds. You can pick what you want and not have this gigantic application, but at the same time, you're seeing the assets of the converged or multi-purpose database that you can share this schema to get all the spatial, globally distributed database, all these different aspects, which is really kind of the big theme of this and one of the big advantages of Oracle database, right? You have all this different functionality, but you can share the same schema. It's extremely adaptable to all these languages and interfaces, but it's also makes things very simple for developers. This is a very developer-driven presentation we're giving here. So along with that, all of these can be run in Kubernetes or standalone. So each one of these in the GitHub repo has its own directory, and there's a run script for standalone, and there's a run script for deploying to Kubernetes. So super easy and flexible. And then each page has a developer details button that opens up to show you some developer details. So you'll see this as we go through it, but you'll see the app, and then you'll see a section for developer details that you can expand to see a video that elaborates, links directly to that code in the repo, differentiators, and then links to backend tools, like the Jupyter notebooks and things like that. And then within the app itself, we also have code snippets, the very vital 5 to 10 lines of code or whatever it is, the key code snippets. And they're displayed next to the app, and they change when you change options in the app. Okay. So just to give you an idea as we're walking through the structure. And then these are all the items we're covering. So let me get into it. First, I'll start just with the architecture. So again, you don't have to deploy this in Kubernetes, but it is set up that way. And these are the technologies we're using. So, we going with the most popular technologies. So what you're looking at here is a React app for the front end. And then it's calling into various backend stacks. So, the three popular ones being MERN, the JavaScript stack, essentially. And then the Spring Boot backend, particularly for financials, that's the most popular. That's like 90% of Java deployments are Spring Boot. And then Python, which has become, incredibly popular with AI over the past few years in particular. So this is everything that's in it. This is what I mentioned as far as the entity diagram. Even though you can do this modularly, this is what the shared schema looks like. And again, this is the link right in the app to the source code and the link to the workshop. And then, as I say, developer details in each. So let's move on to ORDS, which was maybe the most popular on that survey, actually. And I'll let Armand take over.
Right. So I'm not sure if you're familiar with ORDS. You probably are, but it's basically exposing tables, views, etc. as a REST API. And it's a very powerful feature. It is so powerful that we use it internally a lot. For example, DB management is based on ORDS. Our MongoDB API is based on ORDS. For example, if you want, you could basically create like an observability endpoint, for example. You have a database performance tables, like sessions, that kind of stuff. You could easily, expose those using auto rest or something like that. I'm going to just cover that in a little bit. And you can basically create your own endpoints there because it's a REST endpoint, right? So it's very, very, very powerful. So I wanted to show you in this video, we have in minute, say 2:16. Just give me one sec. So the basic features of ORDS. So you have something called auto rest, which is basically, hey, I have a table. I want to make it REST enabled. And you just go click on enable and you're done, basically, right? Obviously, you can configure like authentication, et cetera, but we're basically done by saying, I want this table to be REST enabled. You can do that via UI, which I'm going to show in a few minutes, in a few seconds. But you can also do that via SQL. So you can just go ahead and use SQL, PL SQL, and just do that. So you can get page responses from this REST capability as JSON, for example. They were via HTTPS. As I said, you can configure authentication. What I'm going to show right now, that it's not using any type of authentication, but just for the sake of simplicity, right? You can define and control it via schema. So you can define the schema. We have a great support, full development support. You have a GUI, you have a CLI, API access, SQL, as I mentioned. So it's very, very usable from a developer standpoint. And this is a core feature of autonomous database. So basically, ORDS is a core feature. You can enable it straight from the OCI pages. And I'm just going to go ahead and just give you like a very quick demonstration. We cannot do anything advanced, but at least I can show you how to get into it so you can start exploring, right? So here I have my autonomous databases. And this is a serverless, almost database serverless implementation. And as you can see here, I have database actions, right? So in database actions, I have quick links to SQL, REST, etc. If you click on REST, for example, clicking here on REST, opening up. And this is basically like a dashboard for ORDS. So you will see all the things that you are exposing via REST. Like for example, if I click here on the tour, you will see that you have objects or modules that you are supporting right now. You have a metadata catalog, which is basically the endpoints that you are supporting for ORDS, different modules that you will have here. So everything is listed here, even the security, how you're dealing with security for each end. Okay, and here is like a basic list. Just let me show. Here, like a basic list of the endpoints that you're exposed. All right. So here we haven't, as you can see, you see auto rest is 0 because I haven't created any auto rest implementation. I'm basically exposing the table as rest. So that's what I wanted to do right now. Okay. So if I click here on database actions and SQL. Okay. So this is SQL access to my autonomous database, serverless, and I created a customers table. So just to give you an idea, I'm just going to copy what I did. I'm not going to do it again because it's already done, but basically I created a customers table and I inserted like five customer entries, okay? And now this is very, very simple. I'm just going to right click on customers and I'm going to say REST enable. Okay. Here I can decide on different things where I want to require authentication, etc. I don't want to require authentication. I'm just going to do enable. Okay. And now if you just right click and you see REST, you have the option to disable. This is enabled. So this table, customer table, is already a REST endpoint. Okay. And if I click here on curl commands, basically I can copy this command, which is the curl to basically hit that endpoint and get all the customers. I'm just going to paste it here. See if I get a response. See, there you go. I have all the customers. And obviously you have the possibility to get a single customer. For example, give me the customer with ID 1. This will update the core command here. And if I copy again, basically request the first customer. And take a look at what I did. It was a one-click operation. I basically said REST enable, and that's it. I have a fully blown REST API for this table. Obviously, it gets more complex than this. We support post, delete, put, etc., all the verbs, and you can do a specific authentication, etc., combine tables, etc. But I'm not going to go through that because we have a lot to cover today. But basically, if you just want to play with it, just go ahead and do exactly what I did here with your tables, and you can start get up and running. Right. Let's move on to the next topic, Paul.
Yep. So we were going to talk about the Mongo adapter.
Oh yeah. Okay. Perfect. We wanted to show you how to use basically the MERN stack. We have Mongo, we have Express, we have React, and we have Node, and we are using JSON relational duality. Okay, and the task is basically showing the creation and viewing the accounts. Accounts basically for this very simple financial application. Okay, so what we show here is the fact that you can access the Oracle database using the MongoDB API. So as you probably heard, we have an implementation of the wire protocol of MongoDB. So it's a very, very good implementation for how to connect to the Oracle database or to Autonomous database using the MongoDB wire protocol. So we are simply creating and querying accounts here. Okay, so we can dictate if we will use SQL or MongoDB to do that against the Oracle database. So as you can see, we can choose whether to use MongoDB or SQL. Basically, the end result will be the same, but we can work with the database as if it were MongoDB. Okay, so as you can see in the code on the right-hand side, the code changes depending on which API we use. However, the behavior of the insert and select is the same whether we use MongoDB or SQL APIs. Okay, so the JSON relational duality line on the bottom right. Okay, so we are saying or JSON relational duality. This feature, I think we should stop and mention this feature here because it was introduced in 23 AI and it's extremely powerful. So I'll just cover it briefly. I personally have a NoSQL background, so I come from NoSQL. I dealt a lot with, document databases, object databases, everything that was not relational, right? just to give you an idea. And there used to be a lot of people praising the benefits of document stores over relational. That was the thing at the time. But that's kind of old school right now, kind of nonsense, because we have the Oracle Converse database handling multiple data types, multiple workflows, multiple workloads. And if you combine the capabilities of the Oracle Converse database with features like this, which is JSON relational duality, you can basically decide what type of database you're working against, right? So you can say, okay, I'm going to work with this database just like it's a document store, right? And this is what JSON relational duality gives you. You make this decision, and this can be truly a document store in a practical sense. It doesn't matter the internals. Then the internals might, the database might just store things on a specific representation. But if you can access it like as a document store, you can query it as a document store. You can use even the same MongoDB tools that you use to access MongoDB and do exactly the same thing. So basically, in the developer area, we usually say, if it walks like a dog, it's basically a duck, right? When you are doing, like kind of inheritance and that kind of stuff. So this is basically acting as a document store. Okay. So if I may, I would like to just share my screen 1 sec and then give it back to you, Paul. So we have the relational model, right? And it's highly flexible. Everybody's familiar with SQL. I think SQL is the most used language, actually. So everybody knows about relational. But then you have the ease of use of document store. It's easy to use, easy to map, to language types, easy to store and retrieve. You get a whole bunch of things in the same document, so you don't have to do like relationships between tables, that kind of stuff. But there's a way to map and to even automatically map, all these tables, stores as rows to documents, right? They can be accessed as JSON, thanks to JSON relational duality. And you can even compose views, which is what I'm showing here, where you can say, okay, I have an orders table, I have a customer table, I have an order item table, but what if I want to access this as a single document, where I have an order, object, where I have everything there. This is what we are doing here right now, thanks to JSON relational duality. We're composing a view to basically have all of those, items in a single document, okay? So you just craft these views, and then you access these views, and you have your document, okay? Obviously, there are automatic features here, but if you want to just compose a specific document, you can just create it, right? So I'm coming back to you, Paul, for the next topic.
Okay. Yep. Yeah, that was great. Thank you. So this next one is very quick. Basically, all we're saying on this page is that you name the language and, it's supported by Oracle database. So everything we're talking about here, I think there are only two exceptions. I think the Kafka adapter that Arman will talk about later is Java specific. And then the micro transactions that I talk about next support Java, JavaScript, REST, and maybe another one. But other than that, every single feature we're talking about is supported by every language. That's all it comes down to. And, there are different driver types for different drivers. But as soon as a new language comes out, it's within a week or two, either Oracle or, the community has written a driver for it. And so that's all we're really showing on this page, is the adaptability. And so I kind of glanced over and saw why do we need so much scripting these days question. And so that's exactly right. It's, on this page, whatever your language is, that it's supported. So that's all we're really saying on this page. And this is a basic ATM example to put money into the bank. Okay. So moving on to the next, this is, I have to be careful not to talk too much because this is my passion area transactions. And in microservices, this is pretty much everyone agrees. This is the biggest potential hurdle, which is transactions and transaction integrity across multiple microservices. So with microservices, the long and short of it, and not to oversimplify it, but you're introducing network, right? You're breaking services into smaller pieces, and therefore you're doing more network, less in process. And when that happens, that's an immediate need for transactions. There's other, reasons that transactions are required, but that's a big one. And traditionally, two-phase commits and XA protocols are used for this. But those rely on the fact that they're using distributed locks. And distributed locks are for short-term transactions, quick transactions. And if you're introducing this extra network, and if you're introducing different types of transactions, like long-running transactions, those protocols, XA and two-phase commit, are not going to cut it. You're going to have lock held in doubt errors and things like that, slowing down the system. So I say that, but I make sure to be careful because just because you're using microservices doesn't mean you're not using XA and two-phase commit. If you have a very controlled environment where the network latency is low, that's still feasible, XA and two-phase commit. But because of this, the network introduction that I mentioned, the Saga pattern has become, the most popular pattern to use for coordinating transaction data integrity between multiple microservices involved in the same business transaction. So Oracle has a product that's written by the tuxedo guys, so these aren't slackers here, um, called MicroTX. And it actually supports XA, two-phase, and sagas, and actually try, cancel, commit as well, which is pretty similar to sagas. And so what that does is it allows you to demarcate, if you're familiar with, like, say, JTA or .NET or something like that, you can demarcate transactions. And then whatever you do after you start a transaction, whether, if it's multiple services, they're in the same transaction. And so MicroTX is basically like a transaction manager for microservices, right? And so that's impressive anyway. But when it's used in conjunction with another new feature in Oracle Database 23 AI, which is, just absolutely revolutionary, which is called lock-free reservations. And this is another specification actually from the 80s, written by Dieter Gaulick from Oracle back in the 80s. But now it's really found, the requirement for it. And it has two benefits to it. One is straight higher throughput for hotspot fields like inventory. And the way it works very quickly is that, you have your optimistic locking, pessimistic locking. Optimistic locking is your select for update, one transaction at a time, safe but slow. Your optimistic locking, you're keeping a timestamp so you can check when transactions come in, if changes occurred by another transaction before commit, and then you roll back if they did. So old transactions lose. With this new feature called lock-free reservations, you mark a field, super easy to use. It's just a new keyword. You put reservable next to your integer field, your number field. It only works on numerics. Then that's one part of it that we're at now at the column level, at the field level. The second part is that there's an intermediate journal, and that journal is actually keeping track of requests for this inventory field or whatever the hotspot is. And then at commit, and it's handing out promises. That's why it's called lock-free reservations. It's handing out reservations. So old transactions don't lose when it comes commit time, even if another transaction had come in. And that's because of this intermediary journal, right? So that's good for throughput, but this intermediary journal that's used to keep track of things before it's flushed to disk on commit has a second purpose in these distributed transactions that I'm talking about with microservices. And what it does is, because you're keeping this journal, you can reuse that journal and use it as the same thing that the journal for distributed locking like XA and two-phase commit would do. Okay. And so combine that with MicroTX, which is using this lock-free reservation feature implicitly for you, and it reduces 80%. Everybody gives the same number, so I just say 80% of the logic you would have to write yourself with sagas. Because the big problem with sagas is, because you don't have distributed transactions, the developer needs to write all the compensation logic. So the developer needs to keep a journal of what changed. These are all local transactions, so it has to keep a journal of that. And then if something goes wrong, it has to read the journal, figure out what changed, and then do the rollback logic itself. And then if there's a failure during recovery, it needs to start where it left off, find where it left off. It's the most tedious and error-prone area of data-driven microservices. And so we were attacking like the hardest areas. And so to give an example, in this workshop or in this app page, you can instigate crashes to see what I'm talking about. But what it comes down to is you would have to write code like this on the right. And this is greatly oversimplified, but what you can see is you have to save a journal. You have to save a journal every step of the way for the state of the saga and your data. And then when the time comes, read it back, do all the replay logic, like I say. Instead, if you use MicroTX and these lock-free reservations, it literally comes down to this code, where in your saga, you say, there's this new API, lock-free reservations. You just join the connection. And then if you have to compensate, you just call rollback on the connection. And the database has been able to perfectly keep track of all the changes to make a clean commit and rollback, right? So this is it's just an amazing feature for developers because, like I say, you just wanted to move to microservices. Now you have 80% more technical debt and lots of error-prone logic in your transactions. Bad, right? You use this feature and it's as simple as when you were using JTA demarcation. You just commit or roll back like you did before. So really awesome feature for data-driven microservices, like I say. So hoping to go too long, you can tell I'm into that.
Hey, Paul, sorry.
Yes.
There's a very interesting question regarding microservices, which is exactly, is there a limit on how many microservices can be utilized?
Right. Great question. Because that's, it sells blogs, right? Microservices is great. Microservices is terrible. This is how many you need. So it completely is use case driven. So you have the classic Netflix with thousands. And then I have WebLogic and I want a mobile app that's 2, right? And then what we see is, so that's the answer is it's use case driven. But indeed, we do see a sweet spot of between 10 and 20 that oddly enough, the customers, whether it's finance and things like that, that's usually what it comes down to is that amount. Because there is also a cost, right? It is a VM per microservice, even though you may have been running a monolith that took a massive VM. So it's totally use case driven, but yeah, that's, at least 60 to 70% of what I see is that between 10 and 20 microservices. Yep. So great question.
And
All right, thank you.
I have another comment, Paul. You might want to clarify that MicroTX is a library, not an embedded feature in the database. Is that correct?
That's right, exactly.
Okay. Yeah.
Because, and I didn't want to confuse too much because we actually do have a Saga engine in the database.
Right.
But the big difference is exactly that. This one runs in Kubernetes or standalone, but generally it's, you're running in Kubernetes. So, yep, that's a good question.
Perfect.
Yep.
Okay.
Cool.
So
awesome.
Let's move on then.
This is the big one where we have like 4 features. Okay. So if you wanted to take distributed database.
Yeah, let me start with globally and then I leave it to you, okay? All right, so in this page we see purchases and detection of fraud. Basically, if you purchase something and you have a purchase that happens more or less at the same time and it's really far away, we could consider that as a fraud, right? So this is what we are showcasing here. Obviously, for that we use Spatial, to detect the distance. But the use of globally distributed database is something I wanted to basically describe here, and then I'll leave you, Paul, to describe the rest of the features. But I think that the fact that we are using globally distributed database here is meaningful. And why is it that we are using globally distributed database here instead of just a standard database? So the reason is performance at the global scale and high availability. Those are the two reasons. So suppose this is AMX instead of just a demo. The system will probably need to process a massive volume of purchases from all around the world in real time, right? So you can imagine a traditional single database would struggle to keep up in that scenario, okay? So if you take a look at the code snippet, because I want to just comment a little bit on the benefits of sharding here. If you take a look at the code snippet, you will see that the database is sharded by account ID. So we actually have like automatic sharding and then sharded by account ID. But it is a good decision here to use the sharding by account ID because you know that all transaction data for a single customer will be stored together on the same shard. Okay, so if I shard by account ID, all the transactions of a specific customer will be in the same shard. And if I want to quickly compare whether one of those transactions or purchases is happening far away from the other, I will just quickly access 2 of them in a row, for example, for comparison, right? So when a new purchase is made, the system can instantly locate the correct shard using the account ID. It only needs to query that one small shard only once to retrieve the previous transaction location instead of searching a massive global table, for example. And this makes this anomaly check, which I think that Paul, you can demo it if you want. Just place a couple of markers and let's take a look at that. you know.
Oh, can you guys see the pop-up screen? Or is that not shared?
You can
Oh,
describe
okay.
it. Yeah.
Yeah, you'll have to trust me. So it
Yep.
mentions, yeah, that's good to know. Sorry, it mentions that an anomaly is detected because when I right click on this map, these are represent two purchases.
Right.
And yeah, exactly. And so it's saying there's an anomaly detected because two purchases were made within clicks of seconds, at a certain distance. Yeah.
Exactly. And as the number of customers and transactions grow, you can simply add more shards to the database cluster. This allows the system to scale horizontally and handling an ever-increasing workload without slowing down. What I would like to mention now, before just moving on, is that the important take here is that if you take a look at the code snippet on the top right, you will see that we have automatic sharding versus manual. So basically, there's an if there that says, okay, I might do automatic sharding, or I might just go manual and use the account ID as the sharding key. The automatic sharding involves analyzing the query to determine the best route to the shard. So basically, when you go automatic, the system will take a look at the query to see how it needs to route that to the shard. Okay, so this involves like a very small extra overhead. But if you do manual setup and you just choose account ID, you will have to specify the sharding key, as we're doing right now in that snippet, on each connection. Okay, in each connection, you need to specify the sharding key. But the system won't be doing the analysis. Okay, so as a rule of thumb, you as a developer, what you should do is use automatic sharding in your connections when the queries consistently include the sharding key in the where clause. If you're doing a query where in the where clause you see that you're using account ID, for example, here it makes sense to use automatic. I just wanted to stop on that, Paul. And then I let you cover the rest. If you want to cover Spatial or OML for Pi, etc.
Yep.
Just go ahead.
Yep, I'll do it. I'll do it quickly and just show the kind of more of the developer parts because they're both amazing. So of course I'm going to try and make this quick in the next 10 minutes. What do we
Sorry,
got?
and I forgot about the comparison table that you have right there.
Oh, yeah.
Okay, so what I wanted to do is just comment on Raft, right? Raft replication, because you probably heard about that. Globally distributed stream Raft, and you say, what is Raft, right? So it's basically replication technology, because if you have multiple shards, you need to replicate the data. You want consistency, right? You want if a shard goes down, you need to be able to cover that on different shards. You obviously need to do replication, right? So you say, okay, why not use data guard, right? Or autonomous data guards, for example. Raft is a bit easier for developers because it's an active replication technology. So it's symmetric, while data guard is active passive. The management is automated and fully integrated in globally distributed autonomous database. You don't have to set up anything extra. You basically select, when you create the database, you select Raft replication, and that's it. It's very, very easy. The failover is fast and it's automatic. The complexity is is lower compared to setting up data guard, etc. And the typical use case for just going with Raft is ideal for cloud native applications that we are showing here, because it's super, super straightforward, symmetric, active. It's an excellent technology for a typical developer. Now, if you are a classic Oracle customer, you have a great a lot of real estate in when it comes to data guard, passive databases, etc., standbys, and you have a lot of expertise, you might just want to go with data guard, and you can actually do that. Okay, sorry, Paul, just back to you.
Oh, no, it's great. Yeah, that's important. Yep. So the Spatial is probably after transactions, my favorite, but I'll keep it short. So we already showed, what it's showing here is spatial and anomalies. And also through this app, it's using a lot of open source libraries as well. So this is OpenStreetMaps. You name the open source library and it's working with Oracle. So that's another cloud native and open source is all through this application. And so the other thing I'll show here is that, this is the front end of the app, of course, but then you can pop over and use either your own, if you're Python, you're certainly familiar with Jupyter notebooks. So here's the Jupyter notebook of what we're seeing in the app. Behind the scenes, you can do, various changes. And then if you're not familiar with, if you're a Python developer, and there's maybe only one other takeaway from this, full, it has the full MLOps life can be achieved with OML. So an OML for Pi has different libraries that you can use. And also this works very well with other, both Oracle's data science and other cloud providers' data science platforms. So you could do all the life cycle yourself here, but you could use, Vertex with Gemini models against the Oracle database. It's just super powerful. So we're running low on time, but if you're a Python developer, that's one to definitely check out. And that's where you can do your models as well. So real quickly, you could make models in the database. You can say, here's my database table or my view, create a model out of this, use AutoML to pick the best model, create the model, monitor it, things like that, like literally 3 or 4 clicks with your existing data to get these models working. So pretty awesome. So let me move on to Graph. So very quickly here, this is just showing the graph technology in the database. It's just generating transaction transfers and showing circular patterns for money laundering, detecting money laundering. And so this is using open source library. And the big thing I wanted to point out here is, one, how easy it is to create graphs. So that it's just a SQL statement like this. And then two, again, to that guy's, I love that comment. Why is everything scripting or whatever? Why is this or that? There's so many options. And so when you look in the Graph Studio, and again, with autonomous, this is just another, like Armand pointed out, this is just another database actions, drop down Graph Studio. It brings you here and look at all the different language, like any language or standard you can execute and get the visuals of the graph, etc. here. So super awesome. Ramon, I'll hand this to you. I think you're going to take the Kafka messaging.
Yeah, the next page involves the asset inventory management. So this is using the Kafka API, which is compatible with the Oracle database via transactional event queues. So we have a fully compatible API there with advantages, which I'm going to cover now. So the main feature is that this provides us the fact that messaging and database operations can be conducted in the same local transaction. So when you send a message and a transaction is related to that message you're sending, you want those to go together and happen atomically, right? Otherwise, you're in trouble and you have to generate a lot of code, a boilerplate code to actually support those scenarios, right? So in the application, we can compare and contrast that by selecting an asset and the amount and doing a transfer. You can show that, Paul, if you want, like try a transfer there. This involves 2 microservices, an order service and an inventory service. And in this case, we're showing not just purchase, but inventory adjustments too, okay? And what we're trying to do here is compare and contrast the use of Kafka with MongoDB and Postgres with the use of Kafka API with the Oracle database, actually autonomous database, serverless, backed by transactional event queues. So we can instigate crashes here, as you can see, where you see like a red thing, this is something that's wrong, and green is going great. So the main purpose is to show how different technology choices handle system crashes and to highlight the importance of transactional exactly once message processing with transactional event queues. So here, I'm not sure, Paul, I haven't seen what you did, but you probably did a deduction, right, for a specific amount on an asset, okay? And the system is using Apache Kafka for messaging, and in that case, when you run into one of these crashes situation, you will have to basically adjust and do a lot of things on the code side for you to basically detect that situation and do something about it, maybe roll back, etc. While when you do it with the transactional event queues and the database, this is happening atomically, and you just roll back the transaction basically. Both things get rolled back. You don't need to basically correlate events to the database transaction, etc. So this has great scalability actually, after many tests that we have done, and it's very straightforward to replace Kafka API calls with our code. Very, very straightforward. All right, so yeah, let's move on. I'm going to be brief for the sake of time. Okay.
Yep. Yeah, exactly. There's so much. I think if we can get through all of them, hopefully everyone gets the idea.
I don't have more time to cover.
And this is another one. Yeah, exactly. Like this one, it's the simplicity, really. It's the functionality of Kafka with, yeah, everything you said, but the simplicity. And that's kind of the same with the topic of 2025, the AI agents and agentic AI. So this is a very, simple interface here for the app. What's happening is, going along with the financial theme, this is a wealth advisor. And obviously, I have to say, don't use this to automate your stock purchases or anything. But we are working with financial customers. I can't actually name them currently that are using it for exactly that, for this wealth advisement. And so I already have a pre-baked answer here, just because it does take maybe 1 minute. So since we're running low, you issue that, and what it's doing is checking out all of the stocks and the purchases like we just made with Kafka and things like that, and taking your personal data, analyzing it against PDFs for compliance and things like that, and making suggestions based on that. And that's what we get back here. And so what this is on the back end is a page here where I've set it up where you can upload what you want to. So what's happening here is we have a number of agents, and this is using LangChain. So like I say, the biggest takeaway from this is whatever you're using, it's going to work with the Oracle database and better, basically, because for LangChain, you're using the LangChain any way you would, and there's plenty of examples out there for your different agents. So here we have a planner agent, assume the role of an investment assistant. Then the interesting one is the research agents, of course. And so these research agents are using a combination of technologies like MCP to go out and get different data. So one of them is vectorized PDFs. I just loaded in, what did I load in here? Like a Vanguard forecast, just random. Again, don't use this for your own. This is just an example. And then it's using data. That's the big aspect, right? It's using your personal investments. It's not just your chat GPT and what you're going to buy, and compliance reports and things like that. And, feeds from MCP for financial and market information, things like that. It's getting that, doing the reasoning, doing the synthesis, and then bringing back, in this case, just simple text on advice, but it can produce a PDF or a Jupyter notebook or an API endpoint, etc. And so what I'm adding is, if you come back and check on this in a week or so, is LangGraph, and that facilitates more of agentic AI, which there are AI agents, and then agentic AI is more autonomous, and you're using LangGraph technology to set up, they're going behind the scenes and acting things out. So one thing to take away, a big differentiator in the Oracle database, again, you can use this in any language. What I'm trying to show here is you're using LangChain and LangGraph like you would with any, if you're using Pinecone or wherever you're using, you take that code and then just point, to the Oracle database, and that's all it's going to take. So you're bringing in these vector stores, and you just use the Oracle LangChain API like you would the others. The exact same thing. Super easy to bring it over. But you can also use SQL, and you can do all of the embedding creation, the vectorization, and all that stuff in the database. So that's the big simplifier and differentiator, or one of them, is you don't have all this ETL and shipping stuff here and there. It's all local to the database. So it's efficient, secure, and simple for your development. Okay. And the last thing I was going to show, I won't be able to do the demo. I wanted to do the demo because it's kind of cool, is just hooking up speech AI to the natural language to SQL feature in the database. So in the database, there's a thing called Select AI. You give it natural language, it creates SQL out of it and returns it. And this is for any kind of query on your data. Again, this is your private data, private LLM. That's the big difference, right? And so what you can do, and this has been at events all over the world, tens of thousands of people have tried this out. You ask your question, and you can compare and contrast asking the LLM directly or using your database data privately. And it will give the answer back in speech. So it'll talk back to you, and it'll actually talk back to you as an avatar if you hook it up to Unreal. So you can either just hear it or hook it up to Unreal and it'll speak it back to you. Okay. So I better stop there. I wanted to share that. That's a cool demo, but we're 2 minutes to the hour. So
yeah.
Thanks so much.
Thank you, folks.
Thank you very much, guys. Really, really appreciate it. I know it was rushed. There are a few questions. So
first one, yes.
Okay. Does AI feature such as natural language to SQL work with locally hosted LLMs, right? From Llama,
Yep.
Exactly.
Yep, and that's in the workshop too. Locally hosting them on Kubernetes and things like that. That's a great place to scale your local LLMs. But if obviously you could use the OCI services or Meta, that's another beauty of the whole multi-cloud thing. Yeah, so you can use whatever model.
Yeah, this is great.
Or even OpenAI in Azure, for example.
Exactly.
We have a customer doing that.
Right. So I'll launch the poll, guys. Again, I'll just like to really thank Paul and Herman for going above and beyond and doing all these great demo and sessions. I know I think I probably would need 2 hours to get to everything in details, right? But there are still other questions coming in. If you guys can keep taking a look at that, Herman and Paul. And what I'll do, again, guys, I'll share with everyone the links to the Autonomous Database, as I shared at the beginning. Also, the link to the demo, right, that Paul and Herman were sharing today, right? That's the GitHub link, so you guys can copy that and you can run it by yourselves. And do that, right? Final considerations, final thoughts here. If you guys come back to the same link of the session, right, that you came in today, or to the one link that I'm showing there, you're gonna basically see all the links we talk about. You're gonna see the upcoming sessions, right, that we're having in a couple of weeks. You're gonna see replays for all the sessions. You're gonna see slides, right, with all the links that that you will like as well. Okay.
Okay.
All right. So I think that's it for now. I'm gonna keep the session open, and I see that we still have a few questions that need some answers, so we can go through a few here. If you guys, let's see here. Can we have another session to go over the slightly rushed sections?
Yeah, that's great.
Yes, that's a good request.
I wanted to comment on that one because we had no choice but to cover this superficially because of the multiple items that we had to cover with Paul. We understand that, but you need to realize that there's a full lab for each one of these topics, right, that you can go through. But obviously, we can maybe join later for specific sessions with you, Marcos, if there's.
Yes, absolutely. And let me put the link right here.
Then there's another one that says
you guys can search for the labs there. Oh yeah, it's Select AI available on ADB free version.
I'm not sure actually.
Yes, it is. So
okay, awesome.
Yeah. So with the ADB free, you can actually set it up there's a live lab actually called the RAG. We just finished adjusting the Terraform script to be able to actually configure that for you, so you can even get an autonomous database free, run that Terraform script for you, and you get you're able to use. Of course, you need to configure your own provider, right? The only limitation on the autonomous database free is you don't have access to any other services outside your home region, right? Where that autonomous is running, right? Awesome. So you wouldn't have access to OCI, Gen AI, for example. But if you have an OpenAI account, like I have myself, for example, I connected that to my ADB free, and I'm using Select AI and using even the ADB chat app all directly there. So
awesome.
That's a great question.
Do you know if the demo, that RAG demo, requires you to be in 23 AI?
I don't think so. Okay. I don't think. Okay. Well, or maybe yes, because of the RAG specifically. Maybe that's. But I think
because of the vector search. I was thinking that maybe if it uses vector search, you will have to be on 23 AI.
Yeah, you would have to be for the vector search part. Yep. Okay. Can you share the link to run Select AI using free ADBS? Yes. Yeah.
just the RAG demo link,
Yeah. Albert, connect me offline. Connect to me offline, and then I'll give you that information. But yeah, I'll make sure to put it also under the one of the links that we have here on the post on the video, right, when I put the recording.
Yeah.
Okay.
Yeah, that, not to tangent, but real quickly, that JSON dual, I didn't quite catch the whole thing, but there is material on that going in both directions for JSON duality. And on the topic of microservices, it's interesting. Some people are actually using that for the migrating to microservices, the JSON duality views, because you can make an isolated view with that, and that's your microservice view. So there's material out there for sure on that. Yeah.
Absolutely.
All right.
We have more questions. I think we don't have any more questions.
Okay, guys. So again, thank you very much. I'll leave this call open for a few more minutes if folks have any other questions. But in the meantime, I would like to say thank you. Thank you very much, Paul. Thank you, Herman, for the rushed session.
Thank you, Marcos.
I know we'll have more opportunity to share other excitement developer topics as well. Thank you very much, you guys.
Wonderful. Yeah. Thank you guys.